Welcome to the DIY Honda Garage channel. Diagnostic Trouble Code, DTC P050A, refers to a performance issue with the cold start idle air control system in the Honda Civic models from 2016 through 2021. This code indicates that the engine control module, ECM, is not receiving the expected signals from the idle air control system when starting the vehicle in cold conditions. Proper functioning of the cold start idle air control system is essential for regulating the engine's idle speed during cold starts, allowing the engine to warm up efficiently. If this system malfunctions, it can lead to issues such as rough idling, stalling, or difficulty starting the vehicle. When diagnosing this code, it is crucial to utilize the Honda Diagnostic System, HDS, to check for any other pending or confirmed DTCs which may be affecting the cold start idle air control operation. By understanding this DTC and its implications, technicians can navigate through the troubleshooting process effectively. The cold start idle air control system directly influences the engine's idling performance during the initial phase after a cold start. Key components involved include the engine control module, which processes data from various sensors and regulates engine operations. The intake air duct facilitates the airflow into the engine. Any obstruction can lead to incorrect air and fuel mixture, impacting idle performance. The air cleaner housing protects the air cleaner element by filtering incoming air, vital for maintaining optimal engine conditions. Neglecting any of these components can result in DTC P050A being triggered. Locating these components typically involves accessing the engine bay, where the intake air duct connects the air cleaner housing to the throttle body, assuring a clear pathway for air intake. Several factors can lead to the P050A code. A poor connection within the intake air duct can disrupt airflow, preventing the appropriate amount of air needed for optimal combustion. Similarly, blockages in the duct can cause airflow restriction, leading the ECM to flag a performance issue. Additionally, a dirty air cleaner element can hinder the air filtration necessary for a balanced air-to-fuel ratio, potentially compromising engine performance. Another critical area is the throttle body. If this component is faulty, it can cause chaos in airflow and idle stability. Issues such as dirt buildup or mechanical failures of the throttle body can severely affect the engine's operation during cold starts, which ties directly to how the system regulates idle speed. In summary, several interlinked issues can prompt this DTC, necessitating thorough inspection in each area. Symptoms associated with DTC P050A primarily manifest during cold starts. Drivers may experience rough idling, characterized by an uneven or fluctuating engine speed. During initial startup attempts, the vehicle may also exhibit difficulty, where the engine hesitates or fails to start altogether. In severe cases, stalling can occur, particularly right after starting, when idling is crucial for maintaining momentum and stability. Unstable idle speeds may also arise, suggesting that the ECM is struggling to maintain the balance of air and fuel required. Recognizing these symptoms early is vital to prevent further complications and ensure the vehicle operates smoothly. Drivers should be aware that these symptoms can also overlap with other DTCs, so precise diagnostics using the HDS is essential. The first step in diagnosing the P050A code is to turn the vehicle's ignition to the on mode without starting the engine. This action activates the Honda Diagnostic System, HDS, allowing for a thorough examination of any pending or confirmed DTCs logged in the system. It is crucial at this stage to observe if there are any other DTCs present besides P050A. If additional codes are detected, they should be addressed first, as they may be contributing factors to the cold start issue. If only P050A is present, proceed with the following steps to isolate the problem. Understanding the state of the vehicle's diagnostic history is essential, as prior unresolved issues can signal underlying mechanical failures that coexist with the cold start system performance problem. In this step, perform a detailed visual inspection of the intake air duct. This component is integral to delivering the proper air volume to the engine, especially during startup conditions. Look for any signs of poor connections, such as loose clamps or damaged segments that could lead to air leaks. Additionally, check for any blockages, which could include debris or buildup that may hinder airflow. If the inspection indicates that the intake air duct is in good condition, you may proceed to the next step. However, if blockages or poor connections are found, immediate rectification is necessary. This may involve reconnecting loose fittings, cleaning, or potentially replacing damaged portions of the duct to ensure unimpeded airflow. After verifying the intake air duct, the next task is to inspect the air cleaner housing. This housing plays a key role in filtering incoming air and must be free from obstructions or poor connections to work effectively. Check for any signs of wear, damage, or dirt accumulation that can restrict airflow into the intake system. Any irregularities must be addressed to maintain optimal engine performance. If no issues are found with the air cleaner housing, move on to the subsequent steps. However, if there are damages or blockages, they should be resolved, which may mean replacing the air cleaner housing altogether. An air cleaner housing in poor condition can severely affect the air quality supplied to the engine, increasing the risk of DTC P050A. The focus now shifts to the air cleaner element itself. This part is vital for filtering contaminants from the air entering the engine and needs to be kept clean to prevent clogging. Inspections should focus on identifying any dirt, debris, or damage on the element. A dirty air cleaner element can lead to inadequate airflow, resulting in poor engine performance and potentially triggering DTC P050A. If found soiled, replacement of the air cleaner element is necessary to restore proper airflow and filtration. After this step, ensure that the new element is properly installed. If the element appears clean, you can then proceed to verify potential problems in the subsequent steps, maintaining a systematic approach to diagnostics. For this step, you need to allow the engine to cool down until the reading from ECT sensor 1 drops to 122 degrees Fahrenheit, 50 degrees Celsius or less. This temperature is critical because it indicates the engine is sufficiently cool for testing. Once the desired temperature is achieved, clear the existing DTC using the HDS to reset the system. After clearing, start the engine and let it idle for roughly 10 seconds. Following this, monitor the onboard diagnostic (OBD) status for DTC P050A, again with the HDS. If the code remains flagged, this indicates a persistent fault in the cold start idle air control system, leading you to the next troubleshooting step. It is important to take adequate time during idling to reach a stable condition for monitoring. In this phase, you will conduct a throttle body test using the ETCS, Electronic Throttle Control System, test option within the HDS. Verifying that the throttle actuator control valve operates normally is crucial, as an adequate function is necessary for maintaining correct throttle positioning during cold starts. If the test indicates that the throttle body is functioning well, you can proceed to the next step. However, any indication of malfunction necessitates a throttle body replacement. Take particular care during this step, as a faulty throttle valve can significantly affect the air-fuel mixture and idle stability, which are essential during cold engine operation. Next, you will check the mass airflow (MAF) sensor performance. Begin by starting the engine and holding the engine speed at around 3,000 RPM without any load, ensuring that the transmission is either in park or neutral, depending on whether it is a CVT or manual. This speed should be maintained until the radiator fan activates, at which point you can let the engine idle again. It is crucial to watch the MAF sensor values during this time, and they should ideally be within the threshold of 4.1 to 5.7 grams per second. If the values fall outside this range, it indicates that the MAF sensor, IAT sensor 1, might be defective and should be replaced. It is vital in ensuring that the system measures airflow accurately, which is necessary for optimal combustion and engine performance. In this final troubleshooting step, you will perform a check on the intake air temperature IAT sensor. To initiate this, turn the vehicle to the off position and allow the engine to cool down to ambient temperature. This step is important to get a baseline before starting the vehicle again. Once cooled, document the ambient temperature and switch the vehicle back to the on mode. Utilizing the HDS, quickly note the reading from IAT sensor 1. The next action involves comparing this recorded value to the documented ambient temperature. If there is a significant discrepancy of 5.4 degrees Fahrenheit, 3 degrees Celsius or more, it signifies that the IAT sensor is likely malfunctioning, necessitating its replacement. If there is no significant deviation, check for dirt, carbon buildup, or any physical damage in the throttle bore area, as these could also impact engine performance significantly. Once all necessary repairs have been executed based on the previous diagnostics, it's important to verify that the vehicle is operating correctly. This can be done by checking the OBD status after repairs have been made. Use the HDS to confirm whether DTC P050A is cleared successfully and that there are no new codes present. Additionally, observe the engine's performance under cold start conditions to ensure the idle air control system functions appropriately. It's also wise to take the vehicle for a test drive to confirm that no symptoms, such as rough idle or stalling, manifest after the repairs. This follow-up verification is crucial for ensuring that the system is restored to proper working order and that any related issues have also been resolved. To minimize the chances of encountering DTC P050A in the future, implementing a rigorous preventive maintenance schedule is essential. Regularly replacing the air filters and cleaning or checking the air cleaner assembly can significantly improve air intake quality, preventing issues associated with the idle air control system. Additionally, it's wise to regularly inspect all connections pertaining to the intake and air system. These checks should include verifying the integrity of the throttle body connections, the MAF sensor, and related components for any signs of wear or damage. By staying proactive with these components, you ensure that the engine runs efficiently under varying conditions, especially during cold starts. Following this maintenance regimen not only improves vehicle longevity, but also enhances overall performance. In summary, DTC P050A is a critical diagnostic trouble code that highlights issues within the cold start idle air control system for Honda Civic models built between 2016 and 2021. Addressing this code requires a systematic approach to diagnostics, starting with thorough checks of system components such as the intake air duct, air cleaner housing, and the throttle body. Identifying additional DTCs is also crucial before isolating and addressing the P050A code. Following a structured troubleshooting path ensures that all contributing factors are considered. Finally, with appropriate maintenance practices in place, such as regular inspections and filter changes, the likelihood of this DTC recurring can be minimized, leading to improved vehicle performance and reliability. Please like and subscribe to the channel. See you next time.